My dear student, today I am going to teach hybridization. But before coming to the topic, what is hybridization? I would like to take a CH4 molecule and want to discuss that how the atomic orbitals of carbon and hydrogen are going to be overlapped to form this CH4 molecule. Now, if you want to talk about the electronic configuration of carbon, then it would be 1s2, 2s2 and 2p2. And these electrons are called valence electron, and these valence electrons are going to form covalent bond with the upcoming hydrogen. Further, this is the 2s atomic orbital of carbon and this is the 2p atomic orbital of carbon, and this is the electronic configuration of ground state. But carbon forms covalent bond in the excited state. So what's going to be happen? The one electron of 2s atomic orbital absorbs energy and gets excited to the 2p atomic orbital of carbon, and the excited state looks like this. Further, the 1s atomic orbital of hydrogen comes closer to the atomic orbital of carbon and form the covalent bond through molecular axis. After the formation of covalent bond, we come to a conclusion that one bond formed through SS overlapping and three bonds formed through sp overlapping. Hence, all the four bonds are not equivalent, but experimentally it was found that all the four bonds in CH4 are equivalent. So, there should be something happen before the overlapping of these atomic orbitals to form carbon-hydrogen sigma bond, and that something is called hybridization. Now, we will talk about what is hybridization. The intermixing of atomic orbitals of almost same energy of central atom to give equivalent numbers of hybrid orbitals of exactly same energy is called hybridization. Hybridization means intermixing of atomic orbitals of central atom which has almost same energy. After the intermixing, they will give same number of hybrid orbital. That is called hybridization. If you go through the postulates of the hybridization, then the number one postulate says the number of hybrid orbital formed is equal to the number of atomic orbitals involved in intermixing. Means if one orbital of 2s and 3 orbital of 2p are going to intermix, then after intermix they will form same number of hybrid orbital. Here 4 atomic orbitals are going to intermix, therefore we will get 4 number of hybrid orbital, and energy of these hybrid orbital are similar to each other, and these are called degenerate orbital. If you go through the second postulates, then the second postulate says the total energy remains conserved, which means energy of each hybrid orbital is average of the energies of atomic orbitals involved in intermixing. It means the total energy remains conserved before intermixing and after intermixing. If we go through the third postulates of hybridization, then the third postulate says hybridization is defined only for the central atom and not for the whole molecule. Which means if we want to define hybridization in CH4, then it is only defined for carbon and not for hydrogen. Now we are going to see that how the atomic orbitals of carbon going to intermix to form hybrid orbital. This is the 2s atomic orbital of carbon and this is the 2p atomic orbital of carbon. This 2s and this 2p atomic orbital of carbon has almost same energy level. Therefore, these can undergo intermixing, and after the intermixing of these atomic orbitals, it will form hybrid orbitals which has almost same energy level. And number two, whatever the number of atomic orbitals are going to be intermixed, that same number of hybrid orbital will going to form. After the formation of hybrid orbital, the 1s atomic orbital of hydrogen will come closer to the hybrid orbital of carbon and formed covalent bond through the molecular axis. This hybrid orbital is called sp3 because it is formed through 1s orbital and 3p orbital. Therefore, the name of one hybrid orbital is called as sp3 hybrid orbital. In this case, we are seeing that four bonds are formed from s and sp3 overlapping, which are equivalent and has same energy. Experimentally, it was found that sp3 hybridization has tetrahedral geometry, and this is the tetrahedral geometry. It has four faces. A tetrahedron consists of four faces, and the corners are occupied by hydrogen, and the center of this tetrahedron is occupied by carbon, and the bond angle between hydrogen, carbon and hydrogen is 109 degree 28 minute. Now I am going to talk about types of hybridization. Here I have written number of hybrid orbitals. Then we will talk about atomic orbitals involved, means which are the atomic orbitals are involved for the formation of that type of hybrid orbital. Then we will talk about hybridization, then we will talk about geometry, and then finally we will talk about ideal bond angle. If the hybrid orbital is 2, then the atomic orbitals involved are s and p orbital. P has 3, px, py, pz. Therefore, any one of them goes for intermixing. If the intermixing happens due to s and p orbital, then it is called sp hybridization. Means one s orbital and one p orbitals are involved in the intermixing. And the geometry of sp hybridization is linear, which has a bond angle 180 degree, and the number of 180 degree bond angle is 2. If the number of hybrid orbital is 3, then 1s and 2p are goes for intermixing. P has 3, therefore either pxpy or pxpz or pypz atomic orbitals are goes for intermixing. Then the hybridization should be sp2, and the geometry related to sp2 hybridization is trigonal planar, and the bond angle related to trigonal planar is 120 degree, and the number of 120 degree bond is 3. If the number of hybrid orbital is 4, then 1s and 3p orbitals are goes for intermixing. The 3p orbitals are px, py and pz. Then the hybridization comes out to be sp3, one s orbital and 3p orbital, and the geometry related to sp3 orbital is tetrahedral, which has a bond angle of 109 degree 28 minute, and the total number of 109 degree 28 minute bond angle is 6. If the number of hybrid orbital is 5, then 1s, 3p and 1d orbital are goes for intermixing. And one most important thing is dz square is going for intermixing, and the hybridization related to this is sp3d, means 1s, 3p and 1d orbitals are goes for intermixing. And the geometry related to sp3d is trigonal bipyramidal, and trigonal bipyramidal geometry has two types of bond angle, one is 90 degree and another is 120. The number of 90 degree bond angle is 6 and the number of 120 degree bond angle is 3. If the number of atomic orbital is 6, then 1s, 3p and 2d orbitals are goes for intermixing, and the 2d orbitals are dz square and dx square y square. This is the most important thing. The hybridization related to these intermixing is called sp3d2, means 1s, 3p orbitals and 2d orbitals are goes for intermixing. And the geometry related to this hybridization is octahedral, which has only one kind of bond angle, 90°, and the number of 90° is 12. If the number of hybrid orbital is 7, then 1s, 3p and the 3d orbitals are dz square, dx square, or either dxy, dyz or dxz. And the hybridization related to these intermixing is called sp3d3, means 1s, 3p and 3d orbitals are goes for intermixing. And the geometry related to this hybridization is called pentagonal bipyramidal, which has two kind of bond angle, 172° and 190°. The number of 72° bond angle is 5 and the number of 90° bond angle is 10.